All right, welcome back, everybody. So this is section 9.4, going over the homework from section 9.4, that practice D worksheet. Again, you guys will like to see that we do have another worksheet problem tonight, section 9.4 worksheet. But let's get started, shall we? Now, I know I only gave you the back, numbers 4, 5, and 6. You guys kind of left out on that. So just flip them in. Ben, what'd you get for the axis of symmetry for this one? X equals 3. We have the axis of symmetry formula, which is x equals negative b over 2a. We know that a is 1, b is negative 6, and c is 2. So if we plug that in, that's negative 6 over 2 times 1, which, did you say positive or negative 3? Good. It is positive 3. Good. Positive 3. So x equals positive 3. I'm going to go ahead and do a dotted line at 3. There's that. Okay. Did you leave your phone? So we got x equals 3. And then we plug that 3 in. What did you get for your vertex then, Taylor? What did you get for your vertex? 3 comma what? 3 comma negative 7. Let's check that. So we say 3 squared minus 6 times 3 plus 2. So that's a 9 minus 18 plus 2, negative 9 plus 2. Yep, that's a negative 7. Good. So 3 comma negative 7. Now I have to fill out, oh, not yet. What's my y-intercept, Serenity? 2. Where'd you get that 2? Good. It's just the last number, right? It's the easiest one to find. That's just the last number. I'll write it as 0 comma 2, but you're just fine saying it as 2. Now I find 2 other additional points. Again, I know a lot of people have been struggling with finding the 2 other coordinates. Joey, what 2 other coordinates did you pick? What 2 other x values did you pick?
I hit 1, negative 3, or well, 1 and or 2 and 1.
Good, 1 and 2, 2 and 1, whatever you want to say, yeah. And then we take, how do we get those numbers? Now remember that you're at x equals 3 for your axis of symmetry. And if it's x equals 3, you're going to go 2 more points to the left, because that means the y-intercept is on the left side. So I do 2 more points to the left. First number to the left of 3 is 2. Next number to the left of 2 is 1. That's why we choose 2 and 1, or 1 and 2, whatever you want to call it. So let's go ahead and plug that in. Just showing how I would do that here. We've got a 1 squared minus 6 times 1 plus 2, which we get that negative 3. And then we'll plug in 2. Yes. Oh my gosh. You're like a ninja. You snuck up on me.
I've been saying it for minutes. Like beforehand.
She snuck up on me.
Yeah.
She's like a ninja. I gotta watch out. All right. Whew. She scared me a little bit. Wake me up Monday morning, 8:30. All right, so 2 squared minus 6 times 2 plus 2. Negative 6. Yeah. Yes, that's right. Okay. Negative 6. So 1 comma negative 3, 2 comma negative 6. Does everybody see the full left side of the parabola? Make sure you're also filling in your blank with the coordinates here. I want you to write out what the coordinates were that you found. Now we reflect it over onto the other side. Here, here, and here. And now we trace our dots. And there's my answer. Questions about that? How did we do on that one? Did we do all right on that one? Because that one was the easier one of the 3. Let's take a look at the next one. What's weird about this one? Hayden? Okay, how do I put it into standard form?
I just added 8 to the other side, and I got y equals 2x squared plus 8x minus 1.
Very good. Yeah, exactly. All you do is just add the 8x to the other side, and you get 2x squared plus 8x minus 1. You just got to get the x over to the right side, the 8x. All right, so that means my a value is 2, my b value is 8, positive 8, not negative 8, and my c value is negative 1. Okay, so that means my axis of symmetry is going to be x equals negative 8 over 2 times 2, so negative 8 over 4, which is negative 2. X equals negative 2. Is that what you guys got? Let's plug it in. Negative 2 comma something. I guess I should have graphed it. Here's my negative 2 line. And now we'll plug it in. We've got 2 and always go back into the one that you solved for. Y is equal to y times, or 2 times negative 2 squared plus 8 times negative 2 minus 1. Negative 9. Negative 2 comma negative 9. There's my dot. And now I find my y-intercept. Carson, what's my y-intercept?
Negative 1.
Good, negative 1. 0 comma negative 1. Okay. And then what 2 other points? Hayden Tripp, what 2 other points are we going to pick here?
Negative 1 and 1.
That would work. That would be the exact points that I would pick. Let's see what we got when we plug in negative 1. 2 times negative 1 squared plus 8 times negative 1 minus 1. That gives me a negative 7. And now we'll plug in 1. 2 times negative 1 squared plus 8 times 1 minus 1 gives me positive 9. So negative 1 comma negative 7, 1 comma 9. Let's check to make sure this comes out looking correct. There we go. 1 comma 9. Pretty steep, but that's okay. And now I'll reflect over to the other side. Here, here. And now we trace our dots. There we go. Questions about that? Okay. Let's take a look at the last one here, number 6. The height and feet of a soccer ball that is kicked can be modeled by this function, negative 8x squared plus 72x. I said they would be reasonable. This one's kind of not reasonable, but well, you'll see here. A is negative 8. B is 72. So if I want the maximum, it's going to be x is equal to negative 72 over 2 times negative 8, which is going to be 72 divided by 16, which is 4.5. 4.5. Yeah. Yeah. Did you see that came for you? Okay.
Yeah.
4.5. X is equal to 4.5. So 1, 2, let's go. Let's do by 2s. 2, 4, 6. So let's put 2, 4, 6, 8, and then 10. Let's do my axis of symmetry somewhere right there. Right, there's 4.5. Okay. Now to find the actual maximum height, I plug that 4.5 back in. Negative 8 times 4.5 squared plus 72 times 4.5. And that'll get me 162. 4.5, oops, that's a dot above. 4.5 comma 162, which means that maximum height is 162 feet with 4.5 seconds it takes to get there. Okay, so maybe these are going up by 10s, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 40, and 20, 30, 40, 50, 62. Somewhere around right there. If it takes 4.5 seconds to go up, how much time does it take to come down? Another 4.5 seconds. Reaching the ground again. 9 seconds total. What goes up? What's going on? Questions about that? How do we do on that worksheet? Do we do all right? Because I got to tell you, if you can do those problems successfully, especially numbers 4 and 5 there, the two at the top, then you're gonna be right on your way for Thursday's quiz. Okay, let's take a look at our guided notes for today. So transforming quadratics. What we got today? Transforming quadratics. All right. So section 9.4 is all about transforming quadratics. The word transform and transformations. Transform to me, it means to change, right? To change from something old to something new, okay? What we're going to be doing is we're going to be transforming an old quadratic and making it new. And what we're going to do is look at the equations to see what's different about the equations, what's going on in the equation to make that new thing happen. That's what we're going to be looking at today. What in the equation makes those new things happen? We're going to talk about really three kinds of transformations. We're going to talk about transformations that make it narrower or wider, as well as a reflection. We're going to talk about transformations that move the graph to the left or to the right. And we're going to talk about transformations that move the graph up or down, shifting the graph left, right, and up and down. So let's first start off with talking about the transformation that will make it narrower or wider. The value of a in a quadratic function determines not only the direction a parabola opens, but also the width of the parabola. Do you guys remember when I talked about whether the parabola was happy or sad? How if the a value was positive, it opened upward, and if the a value was negative, it opened downward? That was all determined by that first number. That's a reflection, whether it opens upward or down, reflection over the x-axis. Now, I can also tell not only if there's been a reflection, but also whether the graph is going to be narrower or wider. It tells you the width of the parabola. And what we're looking at again is that a value. So take a look at what you have on your page there. If we're talking about the width of the parabola, the graph f of x a times x squared is narrower than the graph of f of x is equal to x squared if a is bigger than 1 and wider if a is less than 1. What does that mean? That means that if I put a number out front, if I put a number out in front of x squared and it's bigger than 1, meaning a whole number, if the value of the number outside of x squared is like 2, or 3, or 4, or 5, then that graph is going to be narrower. That graph is going to be narrower. Let me actually show you by way of the example on our homework. Everybody take a look up on the screen real quick. Take a look at this parabola. What's the a value? 1. What's the a value for the next one? -2, right? The a value for the next one is -2. Now, I'm sorry, +2, sorry. The a value for the next one is +2. Do you notice how the graph of the second one was stretched out more, like the arms got narrower for the parabola than question 1? Question 1, the arms were a little bit wider, but if I put a 2 out front, that makes the arms of the parabola stretch up a little bit. We call that a vertical stretch. It's going to make the arms of the parabola a little bit narrower. Now, if I put a fraction out front, if I put like a 0.5 or a 0.25 or a 1/4 or like a 3/4 out front of x squared, it does not make the graph narrower, it actually makes it wider than x squared, okay? So if I put a fraction out front, it's going to be a wider graph. If I put just a whole number out front, it's going to be a narrower graph. So my question is this: which one is narrower? Which one is narrower? The 3x squared or the 0.5x squared? The 3x squared, right? I have seen questions on the state test look exactly like that. It gives you equations and says which parabola is wider or which parabola is narrower. We know the narrower parabola is the one with the number out front. Okay, the 3x squared is the narrower parabola. Or it might ask you, what is the widest parabola of this set? And it'll give you like 4 or 5 different functions. And what you do, you just take the smallest fraction out of each one of those. So which one is narrower? -2 or -0.25? The -2. Not the -0.25. I get that the negative is doing something to it, but what's the only thing the negative is doing to it is flipping it downward. Okay, that's the only thing the negative is doing to it. So which one is narrower? The -2x squared. Okay, the -2x squared is the narrower one. Okay? So we now can tell whether the graph is narrower or wider based on A. If A is negative, we know it flips downward. If A is a whole number, we know that it's narrow. If A is a fraction, we know it's wide. Okay? Now, what we're going to take a look at next is shifting it around the graph. The first one we're going to talk about is a vertical shift. Everybody box or circle whatever you need to do here. That notation. F of x squared plus k. Now, what was, the number on the end of a parabola, or the end of a quadratic? What was that number again? It had a name to it. The y-intercept, right? This is kind of like changing the y-intercept. If I take the end of the function and add or subtract something to it, all I'm doing is changing, I'm adding or subtracting to the y-intercept. Okay, all I'm doing is changing the y-intercept. Now, if you change the y-intercept, you raise or lower the y-intercept, all you're doing is raising or lowering the whole parabola. So if I add or subtract a number outside, all the way on the end of a quadratic, all you're doing is just shifting that U shape up or down, okay? If it's positive, if the k value is positive, it goes up a certain amount, like this is x squared plus 5, it goes up 5 units. If x squared, if k is negative, so meaning it's a minus, it's just going to take it down 3 units. Okay, quite simple on that one. Okay, flip it over onto the back. Let's talk about horizontal shift. Now, everybody box or circle that rule up at the top, that f of x is equal to x minus h squared. This is the funky one. Okay. F of x is equal to x minus h squared. Do you notice that there's a minus in the formula? Do you notice how it's x minus h? That means that it's actually going to do the opposite of what it looks like in the equation. Like if I were to give you this from the very beginning, you might look inside there and see, oh, a minus 3, that must be a left 3. No, the minus is already in there. So that's actually a right 3. If you take a look at the one down below, that f of x is equal to x plus 5 squared. If it's in parentheses and you're putting a plus 5 in there, that's actually a left 5 units. So what's the difference between up and down and left and right? Well, left and right puts it inside the parentheses. Up and down will put it outside, or there are no parentheses. Okay? Left and right puts it inside the parentheses, and we're adding or subtracting. Okay? If you see a minus, it's going to move to the right. If you see a plus, it's actually going to move to the left 5 units. On the space provided on the right side, I just want to put a couple extra examples. So what if I had f of x is equal to, let's say, oh, I don't want to do one that's down below, x plus 6 squared. What would that do? What type of transformation would that do? Left how many? Left 6. Good. All right, so if f of x is equal to x minus 8 squared, what would that do?
Right.
Travis? Right 8. Okay, let's try to put them together. What if I had said this? Oops, grammar squared. What would that be? Redder?
Left 7, down 6.
Very good. Left 7, down 6. Okay.
But there's a regular whole number outside of 17.
Yes. Yeah. See, there were no parentheses on the vertical, right? There were no parentheses. So therefore, if it's happening outside parentheses, that's when it's minus, or that's when it's up or down. Okay. Okay. Let's take a look here. Let's take a look at some examples. Now, how do we graph it then? Well, I'm really just looking for a sketch. I'm really just looking for a sketch of where the graph should go. Like, for example, what are the transformations here? I see two things that are happening here. I see x minus 1 squared plus 2. Somebody tell me what the two transformations are. Carson.
Right 1 up 2.
Right 1 up 2. Write that in there. Right 1 up 2. Okay, so if it's right 1 up 2, that's shifting my vertex right 1 up 2. Some people might even call this vertex form. And you might even see this written saying, like, what is it in vertex form? When you've got this parenthesis like that, that's what it's called in vertex form. So all you're doing is taking the vertex and moving it from 0, 0, right 1 up 2. And that's your new vertex. That's the vertex of your parabola. Now, does this open upward or downward? Well, look it out front. Is there a positive or a negative? There's a positive, so it opens upward. So we know that this generally opens upward. And from there, it's just a sketch. What do I need to see in the correct spot? I need to see that the vertex is in the correct spot. I need to see whether it opens upward or downward. Okay, so let's take a look at the next one. Negative x minus 2 squared plus 1. Negative x minus 2 squared plus 1. All right, so what does this tell me? Baker?
Oh, that you're going left, or sorry, right 2 and up 1.
Right 2, up 1.
Right. This is negative. Alex, how does parentheses is he left?
No, this tells me something different. What does that tell me?
Oh,
Joey?
it's going down.
It's going down. Pointing down, sad face. What should I say here? Points down. Okay. That's what that tells me. Okay. Don't let the transformations kind of like, mesh into one thing. Each little piece of this tells you something different about the graph. Like, for example, now we know that I could go right 2 up 1. There's my vertex. And now I know that it points downward, not upward. So generally, looks like that. Again, what do I need to see? I need to see that the vertex is in the right spot, and I need to see that it points upward and downward correctly. And let's take a look at this last one. Negative 1/2 x minus 2 squared plus 1. Okay, well, what's the difference between B and C? What's the only difference between B and C? There was a negative up front for B as well. 1/2 in front. Yeah, there's a 1/2 in front. Sorry, I thought you said negative. There's a 1/2 in front. So I know that this does the exact same thing. It goes right to, this goes up 1. This points down. But what does this 1/2 do?
Makes it wider.
Makes it wider. Good. It makes it wider. Wider than what? Wider than the graph before, right? Wider than if there was just a no number sitting out front of that parentheses. So let's graph that. We go right 2 up 1. We know that it points downward, and we know that it's going to be a wider graph. So just generally sketch it being wider. The closer your number gets to 0, like the smaller and smaller and smaller the fraction gets, the wider and wider and wider it is. The bigger the number you put in front of the parentheses, the bigger the a value is, the more and more and more it gets stretched out. Okay, the steeper those lines go up. Okay. Questions about that? Awesome. Okay, let me turn off the video and I'll get you guys your homework.